And this brings us to the next concept that's super important and was recently confirmed, known as quantum correlations. A very important concept described in 1967 paper that, though might be difficult to understand mathematically, in simple terms, basically produces a kind of a special link or a special bond between particles at the atomic scale. And so here these links mean that the state of a single particle is directly tied to the state of another particle, even if they're not directly interacting. And so in the quantum realm, the engine and the hot-cold baths can technically become entangled. They can start interacting and influencing each other in a way that should be impossible for the macro world. Now, in standard thermodynamics and in the world we live in, all of these correlations are completely ignored. But turns out that if you do factor them in, they actually present us with a very unusual hidden source of energy. Energy that in theory can be extracted and used. And that was the focus of the most recent and most significant discovery from 2025. Once again, Professor Eric Lutz, along with Dr. Milton Aguilar, discovered something super cool. First of all, here they were able to discover new laws of thermodynamics for these tiny correlated quantum machines, with the laws in this case showing us that thermal machines operating at the atomic scale can convert not only heat, but also quantum correlations into physical work. And this seems to happen in two different ways. First case is referred to as the thermal case, the usual operation where heat is converted into work just like a standard engine. In this case, this would obviously involve some kind of an atom. But then there's also the athermal case, where these microscopic engines extract work mostly from the entropic sources, such as the system bath correlation, or the correlation between the hot and the cold baths, and not just the heat itself. And so when running both of these regimes at the same time, scientists predict that it's quite possible to exceed Carnot limit, making these engines overall way more efficient. Although in this case,